In this section, we'll focus on the Apache web server. We'll install it, as well as explore its configuration files and discuss its features and become quite intimate with it. Let's open our notes. And we'll label this section Apache web server. And as its name implies, it features a www web server. It's also more than just a web server, and it's also very pluggable or modular. It supports proxying, amongst many other features, and it is the internet standard www or HTTP web server. Now let's set up some tasks, including the first, which is to install Apache 2.2x. This is the version included with Red Hat Enterprise 5. We'll use yum to install it. Now, Red Hat Enterprise Linux implements Apache as the package name httpd:/rpm, as opposed to Apache 2 found in other distributions such as Debian or SUSE Linux. However, the version is identical, the major version 2.2. So with that said, we're going to install it on our remote Red Hat system. We'll SSH as root to Linux CBT serve 4. This should prompt us momentarily for connectivity. And while this gets fired up, that's name resolution taking so long. Let's launch a browser and connect to the repository to take a look at the primary packages. This is the repository. It will be loaded momentarily. And let's check on the shell. It still hasn't returned. And in this repository, once it's complete, we'll Control F to search for HTTPD. And here we see the version included is 2.2 minor revision 3. There are 3 packages: the main package, the development package, which allows you to compile programs, namely modules, against the version of Apache above, as well as the manual or documentation, which can be accessed using a web browser if installed. And it provides all the documentation that you'll find online at apache.org. Let's connect to this remote system, and now we're on. We'll RPM query all grep HTTPD just to be sure that it is not installed, or if it is, we'll enumerate the contents. As you can see, it isn't. So with that said, we'll use yum to install it. So using yum, we'll yum-y install HTTPD. That's the unique prefix. And this will go ahead and attempt to download Apache and install it. It also pulls any required RPMs. Here it's pulled APR, utility APR, as well as PostgreSQL libraries. So now Apache is installed on our remote system. An RPM queryless HTTPD will return all of the embedded icons and images and items that are used by Apache to display errors, as well as to make references to documents and so on. But towards the top of this dump, we see the more important portions of the Apache package, including the fact that the main top-level directory for Apache configuration is etc httpd. Again, this is within a Red Hat framework. So this is the top-level configuration container on RH5. For other distributions, it's etc Apache 2. Let's return to the shell. Now beneath etc httpd, there is a primary configuration container, conf. And in conf, you'll find configuration files, such as the main Apache config file. There's a conf.d. This is a directory where you may drop in additional config files, such as a welcome file, which exists, as well as others, to enable functionality, perhaps PHP, Python, Perl support, Ruby support. It's a drop-in directory to turn on features rather than, or as opposed to, modifying the primary configuration file. So let's just note httpd conf is primary configuration directory, and conf.d is a drop-in configuration directory read by Apache upon startup. Whenever you see .d in the name of a directory within a Linux environment, it tends to mean that you can place multiple items in the directory and have the main process parse it, similar to logrotate.d or zinetd.d. So there's some items that we need to take a look at. Beneath conf there's a magic file, and the magic file helps with determining the type of file that the server is to serve, and that becomes important when knowing or having to determine what MIME type to return to the client. So much of what happens on the web is premised on client-server connectivity and the server returning an appropriate MIME type to the client so that the client knows what to do with the content, such as a MIME type for PDF, which invokes the Acrobat reader or compatible reader on the client, or perhaps one for text or XLS or any other type. So the magic file helps with that. Let's launch a separate session so that we can explore the directory structure while we navigate through the contents of the primary package. Again, we'll connect to 75.199, and when the prompt comes back, we'll be on the box. So magic is another important file. etc httpd logs. This is a pointer, a reference to where Apache ultimately stores its logs beneath var log. There's a directory which contains modules. Again, Apache is modular. It supports added capabilities, added functionality by way of modules. So there may be a module for authentication versus proxying, or one which automatically formats a directory structure so it appears to be an FTP layout, and many others. Let's navigate to that httpd directory. So here's the structure. Logs points to var log httpd. In here, when you start Apache for the first time, default log files will be created. Again, on other distros you might find the default log directory to be var log Apache 2. But within the case of Red Hat Enterprise, perhaps for backwards compatibility, logs really is a symbolic link pointing to var log httpd. And this log symbolic link becomes important because in the default Apache configuration files provided with Red Hat Enterprise Linux, whenever a logging entry is referenced, it's referenced relative to the configuration container etc httpd. So you'll see a pointer of logs / and the name of the log file as opposed to the absolute path / var / log httpd followed by the name of the file. As mentioned, here's conf.d. It's a drop-in directory for added functionality. If we take a look at, briefly, let's navigate into conf.d. And we like to explore the Apache configuration before jumping in because there's so many little pieces to the puzzle. There's a README file, and it tells you that it holds Apache specific, module specific config files. So if you provide PHP support or Perl or some other type of support, you'll find a conf file in here. We see one for welcome, named welcome. And if you take a look, it tells you it enables the default welcome page if there is no default index page. So it does a location match, and it will, if no document or if there's an error, it references the noindex.html. In other words, if there is no default document, it sends us the noindex.html, which we'll see momentarily. And there's a proxy _AJP, which allows Apache to proxy requests to servers such as Tomcat and others. Just some additional support. That's not important at this stage. Let's navigate back to the top level container and continue exploration. So, conf is where the bulk of the action takes place. In here you find two files. It's very simple. The magic file, when you execute file magic, you'll see that it believes it to be a text file. In it there are strings that pertain to the common types of files downloaded by web clients, such as audio, PDFs, video, text, and other types. All those types are referenced from this roughly 13,000 byte file. And then there's the main httpd.conf file. This file has all the directives necessary to fire up the server, including the number of instances of the server that should be loaded, its name optionally, what modules to load, if there are any references to other directories to include, such as conf.d one level up, as well as whether or not virtual hosts are supported, and so on. But indeed, this is the primary configuration file. This is the primary directory, and in the primary directory, httpd conf, the primary config file, this is the primary Apache configuration file. This is where all the action takes place. This file references everything else. So it includes directives which again manage the startup and operation of your server. And you can enable or disable any feature supported by Apache via this file. But administrators have a tendency to split out configuration items and make use of the include feature so that it's much more organized. For example, in a SUSE environment, virtual hosts are defined in distinct files to keep them nice and clean, but then referenced from the primary httpd.conf file for inclusion in the overall configuration. Now, we didn't look at the modules directory. Let's navigate one level up. And before we do, the run link is simply a place where the various PIDs are kept for system processes. So, as far as Apache is concerned, when it starts, it will write its PID file in a directory which is relative to the top level container etc httpd run, and there'll be a run entry, a PID entry, in /var/run for Apache when it is up and running. Modules is also a symlink back to user-lib httpd modules. If we navigate into modules, you'll see the modules that are included with Apache. Pipe the output into WCL, and there are roughly 65 modules included. And they cover everything from what you see here, SUing, to spelling, to proxying, load balancing, logging, you name it. Many of the things that Apache does for us are provided by way of modules, such as its ability to log, or to connect to an LDAP server, or to check our security, or to talk to a DBD file to read it, or to ascertain variables from the environment for which Apache depends heavily upon, or to handle aliases, which allows us to reference content in the web space to various locations throughout our file system, or to support user directories, whereby you'll allow normal non-privileged users on your system the right to publish files from their home directory. There are all sorts of modules, and this is only a fraction of the list of modules available for Apache. So now let's define a new task, and that is to explore the main Apache configuration file, httpd.conf. And then after we've explored the file, we'll fire the server up and attempt to use it. So explore etc httpd conf httpd.conf. Let's return to the shell. We'll do so using nano, as it's quick to parse from the shell. So we'll navigate into conf, and there's that main file. Now, the httpd.conf file, regardless of distribution, is a generic file derived from the distribution of Apache, and it is heavily commented, describing the directives that are included. If you scroll down through this, beyond the first set of comments, you'll see directives that pertain to the server as a whole. It's called a global environment. There's a server tokens directive, which allows you to publish information to clients. In particular, when a client accesses a resource that is not available, generating an error such as a 404, then you'll see the Apache Server Tokens OS return. So, for example, on this repository, if we attempted to access a resource that doesn't exist, such as index.php, Apache will respond returning the server tokens. In this case, on the SUSE box, it returns that it's Linux and SUSE, nothing else. Whereas there are other tokens. If you look up the server tokens directive using your local version of the documentation or the version at the Apache website, you'll see the additional tokens that may be enabled. The server root. This is the top-level directory as far as the running Apache instances are concerned. And we say instances because multiple instances are loaded whenever Apache is started by default. So Apache sees the root of its file system as etc httpd. Of course, since Apache runs as root, it has access to space outside of etc httpd, but for the intents and purposes of restricting connecting clients, their root is locked in to etc httpd in terms of connecting to configuration files. So Apache processes its configuration files from the top level etc, lower level httpd, which is where we are in the directory structure. The file that's to be created. If you remember, we did mention that the symbolic links for logs and run are referenced from the primary config file. If we navigate to etc httpd, we'll see those symbolic links, and run really points to var run. So for the server PID that gets created, the PID file directive references the symbolic link run http.pid. So when this server starts, it'll use the symbolic link run and create a PID file or a process ID file beneath var run, as do other processes. How long before timing out a connection? 120 seconds. Whether or not keep alives are to be on or off. Keep alives provide a way to speed up connectivity between client and server so that the sessions aren't torn down as often. Turn this on if you notice any performance degradation. The maximum keep alive requests per connection is 100, so within a given connection, a client can make up to 100 requests before the server will stop serving that particular client. And this is done so that one or more clients do not overwhelm the resources of the server. The number of seconds to wait for the next request from the same client, 15 seconds. So within a given connection, a client has 15 seconds to make another request. Apache runs in various modes, and if it runs in the pre-fork mode, it follows the following directives, or it uses the following directives. Pre-fork mode is also known as classic mode, in that it forks n number of servers and will start up to maximum number of servers to service clients. So in pre-fork mode, the Apache server, the main process, starts 8 instances. The minimum number of spare servers that it will keep are 5. So if it starts and 3 servers are being used, 5 are free. If the 4th server is being used, then only 4 are free, and it will need to start an additional server up to a maximum number of 20. There are limits set for the server and for the client. So let's scroll down. We'll use Control-V to advance one page full at a time. And we have another mode of running Apache. This is the multiprocessing mode. And in this mode, it will start 2 servers, both multiprocessor aware and both multi-threaded. And it has its limits of clients, threads, so on and so forth. So Apache runs in 2 modes. One is in pre-fork mode, where it launches distinct processes up to a maximum of 20 spare servers to handle requests. And also in multi-threaded mode, where it starts fewer servers, but each server is free to launch distinct threads to handle the processes. The listen directive governs the port or ports that Apache listens to. By default, being a web server, it listens to port 80. But it could be programmed to listen to any port, such as 443 for SSL, 8080, or any port between the standard ports up to 65535, so long as the port that you choose isn't being used by some other process. We did mention that Apache is modular. It supports DSOs, or dynamic shared objects. The modules that we saw loaded in the module directory are referenced from the httpd.conf file, the main file. In other distributions such as SUSE, the loading of modules are split out much neater into separate files. But in Red Hat, it's lumped into this main configuration file, so you just have to deal with it in one place. But it works nonetheless, works just like it does in other distros, just not as organized. So the modules that are loaded are indicated in this file, and they're loaded using the directive load module, the name of the module, and the path to the module. And again, this path is relative to the top level configuration directory of etc httpd. Again, that's the server root directive. So back to our server root for a moment, we see that there's a symlink to modules which contains the modules that are loaded. Not all modules in the modules subdirectory beneath the modules symlink to user live httpd modules are loaded. There are other items that are not loaded, but the common items, such as authentication-related modules, are loaded. There's one for LDAP, so if you in fact have LDAP services in your environment, you can tie Apache into it, perhaps for authentication. Logging, environmental variables, and many other modules are loaded in the load module section. Now when you're using Nano, if you want to know the percentage of a document, execute Control-C, and this tells us that we've navigated a fifth or 20% of the document. So there are many more comments and directives to go. We did mention that when Apache starts, it reads the primary httpd.conf file. It also includes any .conf files located in the conf.d directory. So if you drop or deposit items into conf.d with a suffix of .conf, they'll be parsed and included in the overall configuration, which means the README file is not. And at this point in the main configuration file, the files with conf suffixes in the conf.d directory are included. Let's keep going. Whether or not server status information is enabled, it reveals more information than is necessary and is usually used for debugging. The user and group that Apache should run as, by default, the processes that handle inbound traffic run as the non-privileged user Apache and the non-privileged group Apache. So we're exploring it. We know that Apache runs as Apache as something to keep in mind. HTTPD runs as Apache. On other distributions, such as SUSE, you might find that Apache runs as a www base user like www run. But at Red Hat, it runs as a user Apache and the group Apache. Now beyond the global configuration section, we find section number 2, which covers the main server's configuration. Apache maintains a main server distinct of or independent of the virtual hosts. And these are things that we should be noting along the way, in no particular order. So Apache maintains always a main server, which is independent of virtual hosts. This server is a catch-all for traffic that doesn't match any of the defined virtual hosts. So there's a catch-all, there's a default server which serves content out of a directory which we'll see momentarily. And when you move on to virtual hosts, beware that Apache will reroute traffic to your main server if the connecting client does not meet or match any of your virtual hosts. It tells you that in this section as well. Now, what are the key directives for any Apache server? By the way, the directives you find here in the main server configuration apply for the most part to virtual hosts as well. So you can learn about how to set up your virtual hosts by studying the directives defined in the main server configuration section of httpd.conf. Here's an important variable: server admin root at localhost. If there's an error connecting to content or accessing content on your server, the server admin email address will be returned. Now, you may want to make it something such as webmaster@yourdomain, or maybe a fake or fictitious email address, but nonetheless, you should define a server admin per virtual host and for the main server. Server name is currently commented out. In this mode, it handles everything that doesn't match a virtual host. With virtual hosts, you'll see that it becomes very important that we define a server name, because Apache will rely upon the client request to determine which virtual host to serve based on the server name, especially when using host header information as opposed to IP-based virtual hosts. Whether or not canonical names are on or off, and this deals with self-referencing URLs. They're turned off by default. The document root, very important. This references the location in your file system where the default pages for the server can be found. In this case, var www.html. Other distros like SUSE places those documents in serve www.htdocs. A quick LSL of this path reveals nothing, and we saw with the welcome.conf file, if there are no files defined, then the noindex.html file is referenced. In other words, whenever the error is trapped, then at least the default welcome page is served. But if there is a default document, such as index.html, in the var www.html directory, then this server will serve that content to the user and not serve the default page. For each directory that you define that Apache is to have control over, from the root on down to the deepest levels of your directory tree, you should apply rules. And the directory directive allows you to do that, to apply rules on a per directory basis. The main configuration file contains a directory directive for the root of the file system. It allows the following of symlinks, and it allows no override from the root of the file system. No override, or allow override none, means if a user places an htaccess hidden file or a file that's read by Apache that contains directives, Apache will ignore the file. So the only thing that may occur from the root of the file system is that Apache will follow symbolic links. So if there's a symlink at the root of the file system which leads to a directory that Apache is permitted to serve, then it'll follow the symlink and serve the content. But this catch-all directory directive for root doesn't influence the document root. It simply influences the root of the file system. It's a way of restricting web users from being able to access content in the root of the file system, as you generally would not want to do that, because then users would have access to your configuration structure beneath etc to determine how your server is configured and potentially compromise your system. Now, beneath the directory directive for /, there's a directory directive for where content is to be served, var www.html. The rules here pertain to content that will live in and below var www.html. So let's just note as another thing regarding this file, and that is that the directory directive governs file system access. So it governs how Apache will interact with that file system path and present it or not present it to connecting users. We should just note the primary Apache process runs as root and has access to the full file system. However, the directory directive restricts the web user's view of the file system for valid reasons, of course. So now we see a directory directive for var www.html. Everything between this directory directive block pertains to the file system path var www.html. It governs what's possible from Apache's perspective. We see that options are turned on. If content is served from var www.html, which it is for the main configuration, indexes are permitted, which means Apache will formulate a directory structure and present it to the user, similar to viewing it using FTP. If symlinks are defined, Apache will follow them. No overrides are permitted, which means if a hidden htaccess file is present, it will simply be ignored. So far, the rules, the options that are turned on for var www.html include indexes and follow symlinks. But the reason why you will generally not see a list of files enumerated from var www.html is because if there is no default file, such as index.html, the welcome.conf file will see to it that we're served the no index file. So to see the indexing at work or in action, we would need to disable the welcome.conf, which we'll look at in a subsequent section. Let's continue exploring. Now, before the directory block for var www.html is closed out, there's some rules. There's an order in which content and permissions may be applied. In this case, the order is set to allow, deny, allow from all, which means all users can connect to content served from this directory. There are no restrictions. The order allow, deny, coupled with allow and deny rules, allow you to allow or deny access based on criteria such as a connecting IP or a connecting subnet or a connecting host name. Allow from all means everyone can connect to the content. There are no restrictions. But we'll show you in the security section how to restrict access to specific connecting clients, even specific subnets, since we have multiple subnets to test with. So now the directory block is closed out, and then we're in a section which covers the handling of a particular module. There's an if module directive, and it is used to test whether or not a module is loaded. And if it is loaded, then various directives are followed. So if mod user directory is called, then it follows the rules you see here. User directory is set to disable, which means users will be unable to publish content from their home directories. If you want to override this feature, then change disable to enable. Ensure that the mod_user_dir module is loaded, and then restart your server, instruct users to serve content or to publish content to their home directories, and then users will be able to access it. And so long as it's beneath the user's home directory and a directory name public_html, providing we uncomment this directive, then the user will be able to serve the content from their web server using the path to the web server, such as an IP address, followed by tilde in the name of the user and the name of the content or a default file. And then many more directives. We'll continue exploring httpd.conf next, and then we'll start the server and manipulate some of its features.